So in our DSC engine, we're of course using an Oracle, right? We're using Chainlink price feeds. Now, this is kind of an assumption that we have in our protocol right now. Price feeds are just going to work. But price feeds are a system just like anything else. And we should add some checks in our code here just to make sure that if this breaks or if something in here breaks, our system isn't broken. So what we're going to do is we're actually use that library methodology we made years ago to write some checks on this price feed. So I'm going to make a libraries folder, and we're going to make a new contract in here called OracleLib.sol. And what we want to do is we want to check to make sure that these prices aren't stale. If we click on any one of these prices like ETH, USD, let's scroll up to show more details. You can see they have this heartbeat where a new price should show up at least every 3,600 seconds. I believe what this is, right? Yes, on the Spolia testnet. We want to write some checks to make sure that this is actually updating every 3,600 seconds. And if it's not, we should probably pause the functionality of our contract. So we're going to make a SPDX license identifier MIT, pragma solidity like this. We're going to do a library, OracleLib, and let's put a little nat spec to explain what this is going to do. Say at title, Patrick Collins, title, OracleLib, at author, Patrick Collins, at notice, this library is used to check the Chainlink Oracle for stale. If a price is stale, the function will revert and render the DSCE engine unusable. This is by design. So we're going to say, hey, if a Chainlink price feed is stale, just stop. Don't let anything happen. Because if a price is wrong, if a price is bad, our whole protocol is kind of bunked, right? So we want to just freeze everything. So we want the DSC engine to freeze if prices become stale. So if the Chainlink network explodes and you have a lot of money locked in the protocol, too bad. This is something that's going to be a known issue, right? If the Chainlink network blows up and all the prices become stale, you're kind of screwed, right? And maybe this is something we want to account for. But for now, I'm just going to say that's a known issue and we're going to move on. And this is where you'll see me start to get more and more particular about stuff. This is where, as we get more and more advanced, this is where the details start to matter more and more, right? All those little things that I kind of gloss over, they start to become more and more important as this becomes closer and closer to a real production product that should go to audit, right? So let's create a stale price check function. So we'll create a function, stale price check. And we'll have this stale price check be on an aggregator v3 interface.sol. So I'm actually going to copy this, paste it in here, toggle the word wrap. And so as an input parameter, it's going to take aggregator v3 interface, price feed. This will be a public view, which will returns a uint 80, int 256, uint 256, uint 256, and a uint 80. The same return value of the latest round data function in an aggregator v3 interface. Function like this, uint 80. Okay, cool. And in here, what we're going to do is we're going to call price feed dot latest round data. And I'm even just going to cheat a little bit. We're going to control click into this. We're going to copy this line, paste it here, equals, boom, just so I don't have to type as much. Cool, we have all those. And what we're going to say in here, and we're probably not even going to use all these, we're going to have some stale check, right? So each one of these price feeds has their own heartbeat. So we probably should ask them what their heartbeat is, but I'm just going to hard code it for this one. I'm going to say uint 256 private constant timeout equals 3 hours. And this is a constant in Solidity. It stands for 3 times 60 minutes times 60 seconds equals this many seconds. So looks like this heartbeat is actually much longer than the one that Chainlink should allow. So 360 seconds is 3,600 seconds is just 1 hour, right? We're going to give it 3 hours. So what we're going to say in here is we're going to say, first we're going to do a U256 seconds since equals block.timestamp. And then we'll have, minus updated app. And then we'll say, so this will get the current block timestamp minus this updated app. So this should basically get us the seconds since this price feed was updated. Then we'll say if seconds since is greater than our timeout, then we're going to revert with a new error, OracleLib underscore stale price, like this, revert with stale price. And then we're just going to return all of this stuff. So return round ID, answer, started at, updated at, answered around. And I'm going to change this name to stale check latest round data. Now, what we can do, since this is a library on our price feed, we can use this stale check latest round data to automatically check to see if the price is stale. So now in our DSC engine, anytime we call latest round data, we just swap it out for stale check latest round data. So long as at the top we go, after our errors, we're going to put our types. So after the errors, we're going to put types. And so this is where we would do using OracleLib or aggregator v3 interface. We need to import OracleLib. Let's import OracleLib from, /libraries /OracleLib.sol, like this. And now, yep, any place we use latest round data, we can now use stale check latest round data where we have this stale check baked in. And cool. Now we did a ton of refactoring. Let's run forge test just to run this whole test suite, including the invariant test suite. Okay, and stuff's looking good here. And you can see that it even took a lot of extra time to run this last bit. So cool. So we got a little check here. Great. We're not going to write some more tests. This is something that you should 100% do. If we pull up our terminal here, we run forge coverage. What do you think we get? We get this, which you can see there's a whole bunch of contracts that we need to test. This OracleLib could probably use its own test suite, even though it's looking like a lot of it's tested. We probably should definitely test this ourselves. We need to write tests for this. We probably want to test our DSC some more for sure. So we should definitely write some more tests. I'm going to leave that to you with this little finger here.